And I want to start with this repo. So this repo, you also can find the link to this repository here in the description. So here, this is the link to the repo. So this is the main repo for the course. And while we're here in this repository, please, everyone who is watching this, give us a star. So this is how you do this. You just click on the star, and this way you will help us spread the word about the course. So the course is free, and we rely on the word of mouth and social media to spread the word about the course. So you can help us immensely by just giving us a star. And if all of you 500 people do that at the same time, we will get to GitHub trending, and then more people will see it, will give us a star, and perhaps sign up too. So please do that. And maybe I should end the poll now here. So most of you plan to do this. Yeah, so please give us a star. And yeah, so this is the content. It will be roughly, each of these points will be a module in the course. So we'll start with introduction to LLMs and track. This is what we actually will do today too. So the workshop for today is sort of a preparation for me for the workshop, for the course. So we will roughly cover the same content as in module 1. And also, well, more people will know about the course. Hopefully every one of you liked the video that you watched right now on the stream, and YouTube will start recommending the video. You get the idea, right? So mostly this today is going to be module 1, but most likely when the course actually happens, I will re-record that. We will see. And today we will build a question and answer Q&A system for, I'll talk about that later, but we'll build a Q&A system using OpenAI. So we will not use open source LLMs today. It's a little bit tricky because they require a GPU, a rather fast GPU. So a collab is also quite slow, right? And then in module 2, we'll cover open source things. And then you basically see all the topics. I don't think I need to go into details, but at the end of the course, you will be able to build a question answering system. Like the one today, but more involved, more production ready, right? But at the end of today's workshop, you will also have a Q&A system, which is awesome, right? And then we will just build on top of that in the course. So for today's workshop, I prepared a GitHub repository. So if you just, so this is the course workshop. If you just scroll down, you can click on this link here, on this link. And of course, as the course is about to start, we will start putting more and more content here. And eventually what we do today will end up here in this repo. But for now, it lives in a separate repo. And yeah, and this is what we will use today. Okay, so this is the workshop we will do today. And so I just want to tell you what we will build. Maybe I already have an example. No, I don't. Okay, but I'll just show you. So we have multiple courses, and I was talking about these courses. So for example, we have a course about data engineering. So this is the course. No, this is not the course. Data engineering Zoomcamp. So this is a free course about data engineering. And when the course is happening, we have a lot of questions that are repeated over and over again. The questions are the same. That's why at some point we decided to create a list, a document with frequently asked questions. This is the document. And there are questions like, can I join the course after the course started? What should I do before the course starts? You see, like this is the structure, right? So there is a question and there is an answer. And we have 325 pages of content that looks like that, right? Yeah, so quite a few questions. And these questions are repeated. And this document is super helpful for everyone, for students and for instructors. So we, as instructors, we don't need to repeat ourselves often because these questions get asked over and over again. And also for students, they can just go to this document and find it, find the questions there. But also looking for your question in a document with 325 pages is not trivial, right? So what ends up happening in many cases is students just ask anyways, right? Even though the question is there, it's not always easy to find, so they just go and ask. We actually have a solution for that. And if you have done the course, you know that there is a bot in Slack that answers questions. And what we want to build today is something similar to that bot. If you actually want to find out how the bot works, we have a video about that from Alex, who is the author of the bot. I think it was a webinar with where is it? No, you can just look for Alex Litvinov, and this is how to build an LLM powered K-bot. So he explains there how this bot works, and we will build something similar today. So this is what we want to do, and this is also what we want to do in the course. And yeah, I go here, and this is what I described. So we have these FAQ documents, and we need to build a bot or build a system that answers questions from there. And the first thing I already did, you don't need to do it yourself, is extracting the text from this FAQ document to JSON. So there is a notebook with, I think it's called parse FAQ. You don't need to go through this. Only if you're curious how exactly it works, you can go through this document. But the important part for us is this document.json. So this is what we are going to work with today. And this is how the document looks. Let me just open it. I think every time I try to open this document, the hangs like my computer freezes. But yeah, it has frozen again. But this is how it looks like, right? So there is course, then the question section. Yeah, I'll close it right now. Section and the actual answer, right? So this is what we are going to use. And right now I'm just going to go back and look at the plan, right? So first I wanted to talk about like all these terms, LLMs and RAG, what they are. And this is what we can start with. I see there is a question from Ashish, what kind of document it is. It's a Google document. And everyone can just go and edit this. So what an LLM is, it stands for Large Language Model. And a language model usually, like if you use a smartphone and you start typing something, it suggests the next word, right? So let's say if I start typing in chat right now, hi, how, and it suggests how is, how are, how to, and then how are things, how are you, how are the, right? So this is all our phones have a built-in language model. And this model is rather not stupid, but like it's pretty basic. Large language models are large, so they have a lot of parameters and they are a lot smarter. And usually the way all language models work is we have some sequence, some text, right? And then the language model outputs the next character or next token or whatever, right? So, for example, we have how are, and the model outputs you, right? Or it outputs the next possible tokens, right? And yeah, so this is a language model. And large language model works exactly in the same way. So it can, for a text, for the input you give, it starts producing token by token by token. So it generates slowly token by token by token the entire output, right? By just using this language model. And this is such a powerful model that you don't have to think about this as something that continues the output. You can think of this as something that you can ask a question or give some prompt, and then it gives an answer, right? So every one of you has used ChatGPT. Let me open it. I also have ChatGPT. I'll close this so you don't see what kind of queries I used in the past. And we can ask like how to fry an onion, right? And then it starts producing the output. So what I can treat this system as a black box. So we don't necessarily need to know what is inside. So this is some LLM. In this particular case, it's GPT-4. And you give some input and then it produces some output, right? In a very smart way. So let me make it as a black box, right? So prompt goes in, we get answer. And this answer's so good that you can think that this is actually a human that creates these answers. So, and there is a question from Nabit. Will we also learn attention encoder decoder, transformer, RRN, LSTM? No, we will not. So we will treat LLMs as a black box, as a smart thing that resembles, I guess, humans, like the way we would answer questions in a way. So this is just a smart black box where we give prompt and get back an answer, right? And yeah, so this is LLMs, and you can see an LLM here, right? So now we ask the question, how to fry an onion, and then we get an answer, right? So this is an LLM. And then there is another thing called RAG. So RAG stands for RRG, so this is abbreviation. So it's Retrieval Augmented Generation. So we have seen generation right now. So we ask how to fry an onion, and we get an answer, right? So this is generation. And retrieval augmented generation is we get the generation here, the answer from the prompt from an LLM, and we add extra stuff to it. So for example, here, look up in Bing how to fry an onion. So right now we only use generation. So right now an LLM using its knowledge, its own knowledge, answer the question, right? But we can also use a search engine, in this case Bing, and we can get results from the search engine and ask our LLM to answer questions based on that result. So right now, hopefully it will, yeah, it's searching the web. So it's how to fry. Yeah, I don't think I made correct. Look up how to fry an onion. Maybe this way it will work. Yeah. So right now it's searching the web. And so the query it used, we have seen how to fry an onion. And then we can actually see what kind of things it checked, right? So then it took the information from these websites. And based on this information, it gives an answer. So this is actually RAG, right? So we retrieve something we search something, we get the documents, and then we augment the usual generation with the retrieved information. So this is, and this is quite a useful thing, because going back to the example we have, the example, so this is our course, our FAQ. So if I ask ChatGPT what are the prerequisites for the course, right? It will not know. It has no idea what the course I'm talking about. What are the prerequisites? Yeah, it tries to answer something, but of course it cannot, because it needs the information from the FAQ document. So what we want to do is we want to build a retrieval system to get entries from this document and put it into a generator, into an LLM, and ask the LLM to give us the answer based on the documents, based on these entries here. So the way it works is, so let's say we have a user. So this would be our user, and user has a question, right? So question could be like, can I join the course if it already started, or how to fry an onion, or whatever. Right? So then what we do is we actually look up this question in a database. So in case of this example, so the database is the index of the entire internet, right? So ChatGPT used Bing to search for how to fry an onion, and it found like all the relevant websites. In our case, we can put all our entries, all the questions and answers in a database, right? And we can use this database to look up the possible answers, right? So this is, we ask the database and we get back some results. Result 1, result 2, and so on, right? So we get some results. What we can do next is we can form a prompt with these results. So it can be question, user question, then context, results, and then we can ask an LLM give answer to the question using the context, right? So this is our prompt, and again we can just treat an LLM as a black box and just take this black box, right? I'll put it here. So now our prompt goes here to the LLM, and then LLM is smart enough, given the user question and the context, to figure out what's the right answer. We can also tell it use only the information provided in the context, right? Don't invent things. And then at the end, what we get is the answer that we present to the user. So this is how roughly it works, and this is what we want to build today. Right? So we need two components. We need to have a database that we can use for storing our documents, and we need to have an LLM, and then the thing that orchestrates all that, right? So that connects the question from the user, looks up the answer in database, gets the results, builds the prompt, sends the prompt to LLM, gets back the answer, and also, like if we have something like, I don't know, these documents, right? The Google documents, something needs to constantly check the documents, see if they're updated, and put this information into a database. Right? So this is like how roughly RAG systems work. Very like high level overview. So two components and then something that makes the flow, right? And yeah, by the way, like these two things I generated with ChatGPT, so probably it's good. But now we will build this. So for that, we will use Google Colab. no, sorry, not Google Colab. Google Colab is good too, but we will use GitHub Codespaces. Yeah, I was actually thinking if we should use Google Colab, but I like Codespaces because for this workshop we will need Docker here, Docker, and I didn't figure out how to run Docker with Google Colab. So, anyways, let's create a repository. Hopefully, all of you have a GitHub account. If you don't, then you can just create. And let's call it LLM Zoomcamp Workshop, for example. Or you can give it any name you want. Let's add a README and create a repository. And now all we need to do is just click on code, select Codespaces tab. Here, maybe you have local, so select Codespaces and click this button. And now we will have a Codespace, which is nothing else but Visual Studio Code running in our browser. And actually, we can just work here in the browser. So if you don't have Visual Studio Code, like here, we'll have terminal, right? We can just already see what kind of things here. We can edit it. So this is a usual Visual Studio Code that runs in the browser. But I want to use my own Visual Studio Code. If you have it, you can also use it. So I will just do that. So I'll use my local Visual Studio Code. And then you get a feeling that you're developing locally. So this is very convenient. Okay. It's setting up. I think it works already. So now if I open the terminal, I do ls, yeah, it works. Okay, so now we connected to our environment. And in this environment, we already have Docker around whole world. So we don't need to install anything. It already has everything we need. Yeah, we actually need to install some things, but like Docker is not always easy to install. And this one has Docker already, so we don't need to worry about that. We do need to install a few things. So the first thing, we will use pipenv as a package manager. Pip install pip. If you haven't used pipenv, don't worry. It's just a tool for managing virtual environments. So let's say if we have two projects, one project has one set of dependencies, the other project has another set of dependencies. And we want to make sure that these dependencies don't conflict. So we create virtual environments for that. And pipenv is a tool for managing that. So we cover this tool in other courses, like for example, MLOps course or our ML engineering course. If you want to learn more about this tool, you can check it, or you can just ask ChatGPT, what is pipenv? It's not the focus here. And we need to install a few things. So the way you do it with pipenv, I'll just copy it from here. So it's pipenv install and then the list of things you want to install. And in our case, we want to install TQDM, which is a progress bar, notebook, Jupyter Notebook, OpenAI for talking to OpenAI, and Elasticsearch for talking to Elasticsearch. So these are, also, I'm not sure if I told you, these are the two components in our RAG that we will use. So Elasticsearch will be our database that we will use for indexing documents, and OpenAI will be our LLM. Right? So right now it's installing things, and while it's doing this, let me check the questions. There is a lot of activity. Unfortunately, I cannot follow all the questions you have. But yeah, if you see that there is a question you can answer, please help your fellows there in the chat. Is this VM optimized for GPU? I don't think there are GPUs actually in Codespaces. So this is good for this particular workshop, but for the course, we will need to, it's something we're still figuring out how exactly the environment for the course will look like. We're talking to some companies that can provide the students with the GPUs. So if all works out, you will have an announcement. If something doesn't work out, we will find something else, like a different way of doing that. And question from Kritik, what is Elasticsearch? Elasticsearch is a system, is a tool for building a search engine. So you will see, we will not cover Elasticsearch in details. We can again treat it as a black box, but you will see an example, and hopefully this example will make it clear what Elasticsearch is. Okay, now we need to run Jupyter. And for that, we do pip-env run Jupyter notebook. Okay, I don't know what it is, but yeah, so now we run it, and you see that Visual Studio Code automatically forwarded a port. And I think this is what you will not get if you use Visual Studio from the browser. Yeah, probably you will not get it. That's why you need local Visual Studio Code so that you can do this port forwarding. I have not checked port forwarding with the web version. So if you watch this later, to follow this workshop, it seems you need to have the desktop version of VS Code. Anyways, so what happens now is we can just take this link that we get from the terminal, go to our browser and put it there. And now we have Jupyter Notebook running there. And I will start a Jupyter Notebook. So let's call it, I don't know, Elastic print. So yeah, it works. So I think the environment is more or less set up. Yeah, there are a few more things we need to do. Let me check. I think right now we need to configure OpenAI. So we need to get the token from OpenAI. And for that, I want to show you a tool that is called DearEnv. So this is a very convenient tool. So it allows us to keep tokens in environmental variables without exposing them. So right now I'm on a stream and I don't want you to see my token, right? Because if some of you sees the token, you can copy it and start, I don't know, using it somehow, and then I'll have to pay for this. So you have to be very careful with the token. And I also. So that's why I want to use the tool, so then you don't see the token, and I also want to show you how to use the tool. So DearEnv allows us to put all environmental variables, all the secrets, in a file that is called envrc, and it's very important that you do not commit this file to Git, because the moment you commit, it will be picked up by different crawlers. They will see your key and they will start using it. Anyway, so I'll copy this thing. So this is how you install DearEnv. I'll need to create a new terminal. Yeah, the video will stay in the channel. Don't worry about that. And for the course, I'll probably re-record some things. Yeah, but don't worry. So this will stay. And now we have DearEnv. And if I will now need to create a new file, DearEnv. This is where we will put the token, and I will also create git ignore, yeah, and we will put it's envrc. So this is the name, right? So now it will be ignored, so you will not commit it. And here, this is what you put in this file. So you put your OpenAI key there. I will stop sharing my screen right now. I will put the key there and I will continue then with it. So hopefully I'm not sharing my screen right now. So while I'm looking for my key, I'll check it in my phone that I indeed don't share it. So there is a lag between when I say something and the moment you see it. Okay, now I can verify that you don't see my screen. I will now put the key. Okay, well, hopefully it all worked. So I'm going to share my screen again. And now when I open a new terminal, I think I need to do dir env hello. Maybe I forgot to do one thing. So it should say that dir env picked up this environmental variable. So now let me create a new terminal. Yeah, so this is what you should see. So the dir env loaded the OpenAI key, right? So it automatically loads, it puts the key in the environmental variable. So then you don't see this, I don't commit it to Git, and then I don't have to type this key every time I use it. Okay, so what's next? I think the next thing is we'll use the key later. But when it comes to the setup, I think the only thing we need to still do is run Elasticsearch, and we use Docker for running Elasticsearch. So what I will do is just copy this command from here. Yeah, you don't need to know how Docker works. You just need to have Docker. If you want to learn more about the Docker, how Docker works, then we have a data engineering course where we talk in depth about that. And also in our ML engineering course, we also cover Docker. Or you could just ask ChatGPT to explain this command. I'm curious what happens if I do that. What this command is doing. Like funny, it's the chat about onions, but probably it will just, yeah, cool. So yeah, you can, it's a very cool tool. So please use it. We don't need to read the answer. So if you're curious, you can do that. But now we will just check that it is running. So we see some output. Let me create a new terminal, and in this new terminal, I will execute that. So this, we sent a GET request to localhost 9200. This is where Elasticsearch is working, and then it replies with something, right? We don't care what it replies with, as long as there's a reply, and which means that Elasticsearch is working, right? So now it's working. We make sure it's working by using this command, and now we can actually go to our, so the environment is set, we have everything we need. So now we can go to our Jupyter notebook, which is here, and start working, right? And what do we have next? I think I have two things open, right? Let me just close this one, and I'll close this one too. And now, so we finished the environment preparation, and now we will talk about this retrieval part, right? So this part, right? Yeah, this one. So this is the retrieval part, and this is the generation part. So now we'll talk about the retrieval part. Okay, I'll close this too. So this is the retrieval part. So first, remember the JSON document I showed you. We will download it. So we have it on our code spaces, and this is how it looks like. Documents. Oh, what's happening here? So this is our document. So here we have large JSON file with all the records from the FAQ documents. And we need to flatten it. So the structure is we have course and then the documents field, and the documents field contains all the questions and answers for this course. Then there's another course. So this is the structure, and we want to unnest it. So we have just documents, and each entry in this list is a standalone record. I will just show you the code and then we will see what exactly it's doing. So it is opening this document, puts this in memory, and then we go over this document file and kind of flatten it. So now if we look at entries here, we get this part, text, section, and question, but also the course, right? So we just put the course as an extra field to this document. And now we have to check the length of these documents. So we have almost 1,000 documents. Right? So this is what we're going to work with today. So this is already in memory. And now what happens next is we need to put this in our database. So we need to index it with Elasticsearch such that later we can talk with Elasticsearch and get back the results. So we want to build a more small search engine. And for that, first we need to create, so if you have used the relational database before, in the relational database we have tables, right? So I don't know, table with customers where you have customer ID, customer name, phone, and so on. So in Elasticsearch, you have indexes. So it's kind of analogous to tables in relational databases. So we need to create an index and we need to say that we have these fields. So we have the course field, we have the question field, section field, and text field. And all of these three are free text fields, meaning that when we do a search query, we can use these fields to look for content, right? And this course field is more like a keyword. So it's not exactly text because we have only three of them. It's data engineering, ML engineering, and MLOps, right? So let's say if we build a bot for the data engineering course, we only want to consider the questions from the data engineering Zoomcamp, right? And if the question is, can I start the course if it already, can I join the course if it already started? Then we want to use only the answers from this particular FAQ, right? We don't want to use others. So this is what we can do. So it's kind of where filter we have in SQL. Yeah, so this is what we'll use. And now I will create, so first I will connect to Elasticsearch. So we can verify that it works. And we use Elasticsearch library that we previously installed with pipenv. So this is how we connect to Elasticsearch from our Jupyter. And yeah, so we roughly see the same thing. And question, there is a question, isn't Elasticsearch overkill for just 1,000 records? Can we use something like SQLite? I mean, it kind of is, but it's also quite simple to start. So I don't know a simpler way to have a text search on your computer like easily. It didn't take that much time to start Elasticsearch. And SQLite is a relational database, right? So there we can use SQL for, I don't know, maybe SQLite also supports full text search. Because remember, we want to have a query. So the query, the user question, and the user question is a text question, right? And then we will use the question to ask the database, and the database will find the records, the documents that we will index from this JSON file that usually in our case, the way it will work, it will look at the words in the question and if the answers contain these words, right? Or questions contain this word. So this is how it works. So I don't know if it's possible to simply implement it with SQLite. Maybe it is, but we will use Elasticsearch. But it doesn't matter. Like here, it can be any database, so you can freely replace Elasticsearch with anything else. Like as long as you can store documents and retrieve documents, it's good. Right, and now we will create an index. And remember, I said index is like a table in the relational database. And here we describe that there are 4 properties in our documents: the text, which is the answer, the section, And sections are like for module 1, module 2, module 3. Like module 1 is about Docker and Postgres. So then the questions in section 1 are about that, right? Then the actual question, and the course is keyword, because we want to be able to filter on this. So we want to limit our search only, let's say, to data engineering Zoomcamp. Okay, so now we created an index, and we will put all the documents now to Elasticsearch. And to do that, all you need to do is just using this elasticsearch.index, and then you specify the index name, which is course questions. This is the index we just created, and then the document. So we go over all the documents, and for each document, we put each document in Elasticsearch. It should be rather fast. So you see the indexing speed is quite fast. And I see already the question if what are the main differences between Elasticsearch and vector stores, when I should use one or the other. So when you need to use when you just need to use text search, Elasticsearch is sufficient. Elasticsearch also has vectors. You can also put vectors there. And I'm just wondering how to explain it without going into too much details. So we can represent a user query. So for example, query could be, I'll copy it from here so I don't have to type it. So the query from here could be, how do I join the course after it has started, right? And what Elasticsearch will do, it will look at these exact words. So it will look at the words join, course, after, started, and it will find documents that contain these words. And the more, let's say, keywords, and the more these words are, the more of these words you have in the document, the higher the score it will be, the more relevant according to Elasticsearch it will be, right? But what if we have in our database a question that is, how do I enroll in the program after it has begun, right? So the words are different here. So then, like Elasticsearch out of the box will not be able to find answers to this query because the words are different. But if we use, we can turn this query into a vector, and this vector maintains, preserves semantics. So it knows that course and program are similar words, started and began are similar words, join and enroll are similar words. So the numbers we will get at the end will be very similar, very close. And then we can use that for actually looking for our answers. We will also cover that in the course, not right now. I hope I did not confuse you more than before, but this is just the main idea. So later, at some point, Elasticsearch might not be enough, so we may want to consider other things. But for start, Elasticsearch is great, and in many cases, just textual search is what we need. And now I will show you how to actually query Elasticsearch. So it's a little bit complicated. I don't know why Elasticsearch has this syntax. So this is a query we do. Again, this is not, I will not go into too many details about the query syntax for Elasticsearch. You can use ChatGPT. Explain this query. Right, and then it will explain the query. I'll just give you the basics. So first of all, we also only want to have 5 results. So it's similar to limit 5 in SQL. Then we want to say that we want to look the documents, look for the documents that match the user question. And the fields we want to use are text, section, and question. Right? We don't want to use the course field for matching the query. And this head here, question head 3, means that we will give 3 times more importance to questions when the user question matches the question field, we will give it more priority, compared to if it matches the text or section, right? So if, let's say, there is a question that is exactly the same, how do I join the course after it has started, it will be the top result, right? But if this is in text, then it will have, let's say there's another document that has the same exact phrase in the text, then it will have smaller relevant score compared to the one that has it in the title, in the question. So this is our query. And we also have the filter part. We only want to consider the questions from the data engineering Zoomcamp. And yeah, all we need to do now is just execute that. So again, this is one simple line of code. So now we ask Elasticsearch to give us the responses to this query, right? And here we have the responses. It's kind of difficult to read. That's why we can print them. So this is the code you can use for formatting it. So this is the answers. So we have a question: can I still join the course after the start date? I think it's quite similar, right? And yeah, so these are the results we get from Elasticsearch. Section, question, answer, right? And like only this thing is already quite a step forward compared to the FAQ document I showed you at the beginning. So yeah, like for students, it's already quite an improvement. It's much easier to talk to this system and ask a question here and get potential records that contain the answer, rather than going through the entire document and try to find something. Right? So this is already an improvement. And with that, we cover this part. So we get the retrieval part. And now we need to cover the generation part. So now this result, we can simply put to a prompt, put it to LLM, and then an LLM will give us the answer, right? So this is what we will do next. And let me just quickly check last question. So is Elasticsearch database safe of storing company data? Say, I suppose I want to build a chatbot for a company. Yeah, so it's possible. So if you host Elasticsearch is an open source product, and you can host it in, let's say, your Kubernetes cluster if you want. Or you can also use hosted Elasticsearch. It's not called Elasticsearch, it's called differently, but it's the same as Elasticsearch on Amazon, right? And then it kind of stays within your account, so it's pretty safe. So yes, the answer to this question, yes, you can store sensitive data in Elasticsearch, and if you self-host it, then you can be 100% sure that the data does not leave your Kubernetes cluster or whatever. Is it still possible to get hallucination from LLM? Yes, so hallucination is when an LLM invents answers itself. Yes, it's possible. Hallucination is a known problem in LLMs. And again, ChatGPT help me. What is hallucination in LLMs? It will probably say something now. Refers to model generates incorrect or fabricated information. And yeah, it can always happen. So there are some safeguards against that, some monitoring, and this is something we will also cover in the course, how to make sure it doesn't happen. But LLMs are known for that. And ChatGPT, you can ask something and then ChatGPT will reply, and it will be very certain with its answer. So it will not use words like maybe, I'm not sure. It will just reply. And then you just have to kind of double check, I guess. Okay, so where did we start? Did we stop? Right. So right now we want to put this in OpenAI and to an LLM. Right? And this is what we do next. Yeah. So there is one step just to put it in a function. This is a good idea because right now we just have it in cells, Jupyter cells. So now we can put it in a function, but this is exactly the same thing. Maybe actually it should be outside. Oops. So this is the function, and we can use it like that. So it's very similar to what we did previously, except now we put it inside the retrieve documents. So we have the query here, and this is all we need to use where it is. So we just put the user question in this retrieve documents function and we get back the results. Okay, now moving on to the next part, generation part. And this is how we use OpenAI. So we import it, we create a client, and there are multiple ways. You can Google that, find the docs for OpenAI. So this is how we can use it. So this is here in this particular case, we use ChatGPT 3.5, and we ask a question: what's the formula for energy? And if I use, so this is what it's doing right now, right? And probably it will give a very similar answer right now, maybe shorter, maybe longer, but this is a way of programmatically using it. Okay, and I need to stop my Jupyter Notebook and start again because I started it before I like when I did this tier n thing, so it was already running, so I need to stop it. Yes, let's stop it. And then I will open a new terminal with the key, and I will do pipenv run Jupyter. So now it should contain the key. So I will probably need to, what are these errors? I'll probably need to copy this thing. And so what I will do is I will now execute this thing. Yeah, it still works. We should, if I now execute this, this should still work. Yeah, it still works. Because all the questions are indexed by Elasticsearch, so by stopping and starting Jupyter Notebook, we don't lose them. And now let us run this. So OpenAI should work because it used the key. Yeah, and this is the answer. And of course, every time it gives a different answer. Oh, so right now the answer is more concise, just like ChatGPT, right? So right now it gave a large answer, but if I regenerate it, yeah, it gives already a different answer. So here it's the same. Yeah, so it's rather simple, right? So you can also use a different type of model here, but we will use this GPT 3.5 Turbo. And so this is how we can use it. So right now what we need to do is just to create a prompt with the user question and the context, these things we retrieved with Elasticsearch from Elasticsearch, put it together, send it to our GPT, to LLM, and then get back the answer. Which is actually quite simple because like here in this case, we only use an API for an LLM. So it makes it fast and easy. We don't need to host an LLM ourselves. In case we run an open source LLM, then we need to run it. We need to have powerful hardware. But of course, when we use an API, we need to pay for the API. Okay, so this is how we create the prompt. So this is our prompt. But in order to create the context, we need to concatenate all the documents, all the answers together. So this is how we do it. So we just iterate over each of the documents. We create a string, and then we concatenate all the strings into one long string, right? So this is just one string context. This is something we'll put in the prompt. And then the next thing is putting this in the prompt, yeah. So this is the prompt. So the prompt is you're a course teaching assistant, answer the user question here based on context here. The documents retrieved from our FAQ database only use the facts from the context if the contents doesn't contain interesting, contain the answer, return none, right? Which is also good because we talked about hallucination, and if we don't say that, if we don't specify this thing, it will attempt to answer the question even if the context does not have the answer to that, and sometimes it can be a hallucination, especially like if this is very specific, if the knowledge base we have is very specific. Let's say in our case this is specific to the course, so the answer from an LLM will probably be incorrect. Okay, so this is our prompt. Let's see it. So this is what we're going to send to OpenAI. And this is very easy. This is what we already did. This is exactly the same code. And let's execute that. And now we get an answer. So to join the course, after it has started, you can submit homeworks, even if you haven't registered. Just be aware of the deadlines for final projects. Yeah, so very good answer. Yeah, so one thing is, so with this chat API, we can play with different roles. So there is a role user. This is what the user uses to communicate with the chat. And there is also a role system, which can contain some context. So technically, I think we should split this prompt into multiple. So first give the context at the beginning and use the role system, and then give the question using the role user. But here, for simplicity, we just use the same code. It's the same as putting like this, where's the prompt. So let me just try doing this prompt. So this is the prompt. It's the same as just typing it into ChatGPT. So here I did not create a new ChatGPT window, which would be the right way of doing that. Okay, so you see it gave some answer. So we're doing technically the same, just putting everything we have to ChatGPT and getting back an answer. Okay, so now we just need to clean it a little bit, and yeah, then we have our RAG system, Q&A system ready. So let me just quickly check if there are questions. Yeah, recording will be available later. We're now serving the model. RAG works fast, but on local it will take 2. I mean, you can make it scale. So what we show here maybe is not the most scalable version, but like Elasticsearch is scalable. Like if we just use the system like here today, you can make it scale. Question from Marina: is there a way to send context only once? Because if such a long context is sent with every single question, it will be expensive to use such a bot. But the context is different every time, right? So every time, so let's say if I ask a question and then you ask a question and then somebody else asks a question, all these questions are different, right? So it means that the context for these questions are also different. So it means that you will need to send the entire thing every time. So yeah, at the end, it might be expensive, especially if you have like thousands of students. Can you compare results generated from OpenAI versus Mistral AI? How different it would be in terms of performance? I don't know. So I have not tried Mistral AI. I don't know if they are cheaper, if they're better. But like again, here, this is very so to say, composable, or like you just can take one thing out and put something else replaceable. Yeah, so these are replaceable. So instead of OpenAI, you can use Mistral AI, or you can use Llama, or you can use, like, I don't know, any model from Hugging Face, and then it will still work. You might need to adjust the prompt because the models, different or LLMs react to different prompts differently. So you might need to tune it a little bit. And likewise, if you don't like Elasticsearch and you want to replace it with, let's say, a vector database, you just replace this part, and this part can stay the same, right? Which gives you a lot of opportunities for tuning. And actually, what is more, you can even have two databases. One is vector database, one is search database, right? And they will kind of support each other. And this is what actually Google is doing. So they rely on, of course, nobody knows for sure how it works, but from what I heard, all these search engines, they still rely on text search and on neural search too. So they combine the results from both of them, plus some personalization and so on. So this is what we can also do. We can rely on both databases. And if we do this thing still stays the same, right? Because the concept is we still get 5 top results, send them to an LLM and get the answer. Can answers of the final prompt be cached? Yeah. So it can be cached. If users ask the same exact questions, then yeah, you can just hit the cache. But like, will they ask exactly the same question? Like, even if there's one student uses a question mark and the other doesn't, then it's kind of different queries already. So you will need to do fuzzy matching, then it becomes, yeah, difficult. Okay. So I see already there are questions about the course. So for questions about the course, so there is this this thing here in the top. Yeah, please use this for questions about the course. I already see there are many questions. So if it's about the workshop, use the live chat. If it's about the course, use the Slido link. And right now I want to continue because we are almost over. I mean, in principle, you saw how it works. We just want to put everything together, and I don't think it will take a lot of time. What we will do is just put everything in functions. So these are the functions. Yeah, actually, it's a lot faster than I anticipated. So we have multiple functions. So build context is that logic where we concatenate all the documents into one string. Build prompt is another function that takes the documents, concatenates them, and puts them in a single prompt. And then the function ask OpenAI sends the prompt to OpenAI, and then QA combines everything together. So retrieve documents, build the prompt, and ask OpenAI, right? And now we can use this function, QA. So let's see what kind of questions I have. I'm getting invalid reference format. And then, yeah, so we get the answer. There is a lot of room for improvement, of course. So for example, right now, we don't know where the answer is coming from. So it would be nice to include some sort of ID. We want to say, okay, this answer is coming from this part of the FAQ, right? And then you can go there and, let's say, double check the results. So yeah, and this is all possible with what we already have. We can just expand on build on top. So for example, we can modify this part, build context, and then add something like document ID and then ID here, new line, and then we can ask in the prompt when giving the answer also specify the document ID from which you took the answer, right? And then using this document ID you can show, like, it's all possible to integrate. So now we have a basic RAG system, Q&A system. We can build an interface. Let's say it's possible to put it in Streamlit. then deploy it somewhere and students can already use it. Or we can, for example, build a Slack bot, and this is the bot we already have, the bot that Alex built. It's more elaborated, more complicated, but essentially it's doing the same thing. Actually, I'm wondering if I have this Alex, and GitHub. Okay, yeah, thanks Google. So this is the code base. This is what he uses. You can see it's way more complicated, but again, there are two components: indexing, or like the retrieval part, and then the generation part. Yeah, I think you can check how exactly Alex creates the prompt. Probably somewhere here. I mean, yeah, I don't know. You can check it. So I think that's more or less it what I wanted to show. And I see there are a lot of questions like, what's the difference between fine-tuning and RAG? So I'm just wondering if we should answer them now. Yeah, well, we have time. So RAG is when you don't change your LLM. So LLM stays the same, and fine-tuning is when you use all these documents to create an LLM trained on your specific documents. Right? So in this case, if you, let's say you take all these documents and fine-tune your LLM, you will not need the retrieval part. You can just rely on the generator part. And you can ask a question when the course starts, and technically, ideally, the fine-tuned LLM should just reply, give the answer, right? But there are problems with that, right? So let's say users change this. First of all, it's very expensive, right? But then second, users, let's say, change it every day. You don't want to every day retrain your, fine-tune your model, right? So you want every time there is a change, you want to get the fresh results, right? And with RAG, you can do that. With RAG, you can add this point to the sources, right? With fine-tuning, I'm not sure. So fine-tuning makes sense when you have a very specific domain. Let's say you take an open source model that is rather small, and then you, let's say, if you want to build a system for lawyers, for specific, I don't know, let's say corporate law, or whatever. Right? So then you can fine-tune some small model on law documents, on legal documents, on like all the laws, and then the system will be as good as, let's say, GPT-4 or even better for this specific case, but the model will be light and very fast. So this is a use case, a good use case for fine-tuning. In other cases, to my knowledge, RAG almost always better. So let me see. Will using Elasticsearch and LLM API produce better results than Assistant API? I don't know what is Assistant API. Is it like something from OpenAI? I have not used it. I'm hoping we can take these courses even if we are familiar with MLDS. Yeah, you actually don't need any machine learning. So again, like we treat LLM as a black box, which means you don't need to know how machine learning, like anything from machine learning. Okay, I think what I should do now is go to the questions. So if you have any questions now about the course content, go to Slido and use them. Because for me, it's not easy to see all the questions here. And yeah, let me start with these questions. Do I need to know about NLTK and other NLP libraries to work with RAGs? Sometimes yes, sometimes no. So let's say if you want to Like when you use an open source LLM, you will, for example, it's hosted on Hugging Face. And in Hugging Face, when you want to use an LLM, before using that, you need to use a tokenizer, right? Uh, I don't think you actually need to care how exactly it works. You just need to know that first you need to take a piece of text, tokenize it, and then put the tokens to the LLM, right? So apart from knowing that this is what you have to do, you don't need to know anything else. How LLM Zoomcamp will be conducted, which topics will be covered, and will we have our hands real projects after the Zoomcamp? Also, will there be an MLOps Zoomcamp? There will be an MLOps Zoomcamp, and the topics, I think I talked about the topics. I'm just, okay, so this is the topics. It's in our LLM Zoomcamp repo. And at the end, we'll have a project. So maybe I should just mention here. Hands on project. So at the end, you will implement everything we learned. You will put together everything we learned. You will need to implement that. And the way our courses work is at the end of each course, you can get a certificate. And the only thing we care about at the end is whether you passed your project or not. So if you pass the project, you will get the certificate. If you didn't, you will not. And we don't look at your homework submissions. We don't look at whether you actually watched the sessions or not. We only look at your project at the end. So yes, at the end of the course, you will get a project that you can put in your portfolio and use it for your job applications, or just, I don't know, keep it because it's a cool project. And you will need to actually, so in this case, for the course, we will use FAQ documents from our Zoom camps, but for your project, you will need to find a different data set. Is it possible to collect data from multiple PDFs into a table for further processing? Yeah, you can ask ChatGPT how to do this, but yeah, it's possible. Love your courses, landed a job after ML Engineering 1, thank you. Yeah, you're welcome. It's always nice to hear things like that. MLOps and LLM courses overlap time-wise. Yeah, no way we can have them non-overlapping. No, we cannot. And this is something I talked about at the beginning. So the thing is with our courses, so we have in September ML course, then we have in January data engineering course, and then in May MLOps course. And these three courses take the entire year, right? And now there's a problem. If we add a fourth course, where should it go? Should we remove one of the courses, or should we run it into parallel to one of the courses? So we decided to go with the second option. So you will either have to choose, which is probably a better approach, or do both and see if you can handle it. I don't know. I've heard that our courses are challenging, which is a good thing, I guess. So yeah, you might not, you will need to see how it feels, right? So if it's easy for you, then go for this. But at some point, you might have to decide. But also, all the courses are available at the self-paced mode. So all the content stays. And then you can just, let's say, finish the MLOps course and then come back into the LLM course. What kind of database is suitable for LLM racks? If my database comprises of XML files with semi-structured data, not free text, can I use LLM rack for Q&A? Yeah, you can use something like Elasticsearch. Like Elasticsearch doesn't have to have text data, or like depends on what you mean on semi-structured, right? So if there's still some text data you want to use for searching, then yeah. Otherwise, you can just put it to a relational database, and then so you will need to figure out how to turn the user question into a SQL query. And I think you can use also an LLM for that, for turning the question into a user query, right? And then you send the SQL query to your relational database, you get some results, and then you construct a prompt, and then you pass this to an LLM and get the answer. Okay, close that. So yeah. What tools frameworks we will use throughout the course? LangChain, Llama Index, Elasticsearch. So we'll not use LangChain, we will not use Llama Index, we will use Elasticsearch at least in module 1. It's kind of still work in progress. Which exact technologies we will use. So it's very likely that we will use Elasticsearch as a vector store too. So we were looking for companies who are interested in presenting their vector databases, but so far we haven't found anyone who would be interested. So that's why, yeah, we decide to go with Elasticsearch. But there is still time, and if you know anyone from vector search vendors, then maybe you can put us in touch, and then we can talk and see if we can use any other technology. If my data set are links to web pages, is it possible for the RAG task to look at the web content? Well, you will need to scroll it, to scrape it. So you will need to use something like Beautiful Soup to get the content of the web page, and then put the content already. Probably you might have to summarize the content. But of course it's possible. Will this cohort cover vector databases and embeddings? Yes, we'll talk about that. I took programming courses in university, but I'm rusty. Any resources you recommend to become comfortable with programming and Python? ChatGPT. I don't know, just build some toy project. I don't know, maybe there's a task you need to automate and you need to do it manually. Try to find a way how to automate this task with Python, and then you'll be more comfortable. And ChatGPT is really great at doing different things. So, for example, in DataTalksClub, we have a podcast. So the way it works is I start a Zoom call with a guest, and this Zoom call is recorded. And then at the end of the call, Zoom places the recordings in a specific folder, right? And at the beginning, I was manually taking the files and putting these files to Dropbox. So then later, these files could be edited and turned into a podcast episode, which means that after the podcast episode, it takes approximately 20 minutes for Zoom to create these audio files. And then I would need to wait, and I would need to then copy these files, and then I would need to know the editors that the files are available, right? It's kind of a lot of manual work. So I thought it would be nice if I had a script that runs every half an hour, checks if there is a new recording in the Zoom folder. And if there is a new recording, it takes the files that are needed, puts them in the right location, and then possibly creates a notification, let's say an email, right? And this is quite easy to implement with Python. You just need to figure out, I use Windows, how to schedule the script on Windows. But it's fun. And I think you can find opportunities like that around you everywhere. This was just one simple example. I am broke. Okay, sorry to hear. Do I really have to shell our dollars for paid APIs for this course? I mean, if you're broke, you probably cannot afford the GPU either, right? Unless you used to mine Bitcoins and you still have a bunch of GPUs that you don't use anymore, and you might just dust them off and put into your computer and use them, then you don't need to pay for anything apart from electricity. But if it's not the case, then it will be challenging. Because if you want to run LLMs locally, you will need to have a GPU. So right now we're trying to figure out to find partners who can give us compute for free for the students. If we are successful, then you will not need to pay for anything. This is what happens with our ML course. So we partnered with Saturn Cloud, and then they gave GPU hours for the students. So let's see if we manage to do something like that with that course, then you will not need to pay anything. But if it doesn't happen, So it's still probable. If it doesn't happen, then yeah, you will need to pay. But I don't think it will be a lot, like $10. Like maybe, I don't know, just don't drink beer tonight and then use this money for the course. Hi, I want to get started with machine learning. I was planning on doing it before this course in June. Would you recommend doing MLOps or? Okay, so this is not related to Zoomcamp. I'm a bit out of, sorry. So you're asking if you should do the ML Zoomcamp or MLOps? I don't know, like neither or both. Like they are not related to this course at all. Like just depends on what you want in your life, I guess. Can we integrate all Llama or other open source LLMs instead of OpenAI? You can. Remember, all these blocks are pluggable and unpluggable, so you can replace, you can put anything you want there. When to use vector search and text search. Did I not answer that? I think I answered that during the presentation. Are there any live lectures as well during the LLM Zoomcamp, or we'll go over lectures on GitHub? So it's something we're still figuring out. Very likely that it will also be a bunch of live streams this year for LLM Zoomcamp. And the reason for that is these tools that we use change so quickly that it doesn't make much sense investing time in producing polished content, because in a year we'll have to re-record it anyways. So probably we'll have just a bunch of live lectures that we will cut and put to GitHub. So then you can later rewatch it. And then next year, maybe we will invest more time in kind of making more production. Yeah, we'll see. So we'll publish all the links on GitHub. You will see, we will together figure it out as the course goes. Is there any document with course timelines, important dates? Not at the moment, but so this here we have the start date, and you can think of each of these bullet points as 1 week. So each module is 1 week. So with that, yeah, you can figure this out. So for the project, we will have 3 weeks. For each module, 1 week. So it is 6 weeks plus 3. Then for projects, we'll have 2 attempts. So you can do the math. We will eventually do this math for you, and we'll have a document with that. But for now, we have not done this yet. So you can just take a piece of paper or open your calendar and figure this out. Any leads on which open source model can run on CPU? Yeah, if anyone finds out, let me know too. Like I found models that run on CPU. Let me actually show you. So what I showed you here, like I didn't show you all the notebooks. So there is this notebook here. And then at the end, so this is what we did today. Like you will see all the code that we produced. But also at the end, you can see I was experimenting with different LLMs. And then I was checking exactly that, which models can run on CPU. So this one from Microsoft, Dialog PT Medium, can actually run on a CPU, right? But it has very limited context. It cannot fit these long prompts. And the answers are kind of stupid, right? So while it does work on CPU, it's not really useful at the end. At least I did not figure out a way to make it useful. This one, on the other hand, seems useful, but it takes forever to run on CPU. So yeah, like it might also, like it's a mini model, as you can see. I was waiting for, I don't know, 20 minutes, maybe 15 minutes to finish, and never finished on my computer. So you need to have a GPU for that one. We will not cover agents as a part of the course. Maybe if we find somebody to deliver a workshop about that, but I was not proactively asking or talking to companies that do that in order to cover that, because we are busy now structuring all the content, making sure the syllabus is great. So then at least the parts we want to cover will be covered well, really well. But let's say if there is a company who specializes into agents and they want to make a workshop about that, and you're watching now this, or maybe you know somebody from such a company, please put us in touch and we can figure this out. Any tips on leveraging use Zoomcamp into jobs? Yeah, do Zoomcamps, do projects. Then in all our Zoomcamps, we encourage you to share what you learn in public. Do that. By the end of the course, you will build a network and then use this network to get a job and your knowledge, of course. How long is the course? I think I answered that question. So if you do the math, you will figure this out. Like 6 weeks plus 3 weeks for the project, plus 3 weeks for the second attempt for the project, 12 weeks, right? And it's also possible that the first module will actually take 2 weeks, depending on how well it goes for you. But this is something that is still to be discussed, announced. Is a question answer structure always necessary to assemble the context in RAC? I cannot think of other cases. It doesn't mean that you always have to stick to that structure. I just don't know, are they like from the top of my head, I don't know other use cases. Yeah. Should we use VMs on GCP? If you want, why not? Like you can run it anywhere. Can we use Google Colab? So Google Colab does not allow running Docker. But I think this question was answered, that was asked earlier, right? Yeah, I think this is what we have time for today. So sorry, I cannot answer all your questions. Yeah, so remember, please like the video, this video. Then under the video, there is a link to our LLM Zoomcamp GitHub repo. Go to that repo and give us a star if you haven't done it yet, because this way you will help promote the course. I've been talking too much. So you will help us to promote the course, and we will have one more pre-course session where I will only answer your questions. So there will be no content, just Q&A. And then on, June 17th, we'll start the course. So do not forget to subscribe to our Telegram channel. You don't have to do this, but if you do this, it's easier for you to get announcements. Or alternatively, in Slack, join the Slack, because all the messages from Telegram will be reposted to Slack by the bot. So either way, you will see the announcements, and keep an eye also on our newsletter, because we also post the announcements from Telegram to the newsletter, right? So yeah, all the important updates, all the important dates will be shared through these channels. So yeah, I'm really looking forward to the course. Now we have to continue working on that because a lot of content is still not ready. I showed you already what we have prepared for the module number 1. It's almost the entire module. Maybe there will be a few more units at the end, but it's more or less it, so you know what to expect. And in the course, we will build on top of that. And this is what I and the other instructors are doing this right now. So that's all for today. Thanks a lot for being here today with me. And yeah, enjoy the rest of your day. And see you soon.